Write the missing number. 1 is done for you. So they've told us that 180 is 20 more than 160. And that's because 180 minus 20 is 160, or 160 plus 20 is 180. So we need to find the number that is 20 more than 237. So we can work out 237 plus 20, so that's 257, because if we start with 3 tenths and add 2 tenths, we have 5 tenths in our answer, so our missing number is 257. A pack of paper has 150 sheets. 4 children each take 7 sheets. How many sheets of paper are left in the packet? So first, we need to work out how many sheets have been taken, because if we subtract what's taken from the 150 that we started with, that will give us the number of sheets that are left. So we know that 4 children each take 7 sheets. So that means 7 sheets of paper have been taken 4 times, and 4 times 7 is 28. So we started with 150 and 28 were taken. So if we work out 150 minus 28, that gives us 122. So that's the number of sheets that are left in the packet. This graph shows the temperature in 6 cities on one day in January. Which city was 4 degrees warmer than Kiev? So we can see that the bar for Kiev is this bar here, and that bar goes below 0. So the temperature in Kiev is -2. So we want the temperature 4 degrees warmer than -2. So from -2, if we add 2, we get to 0, but we want to add 4 degrees, so we need to add another 2 because 2 and 2 make 4. So that means we need the city which has a temperature of 2 degrees. So if we find 2 degrees, draw a line across, we can see that the city is Paris. Now, what was the difference between the temperature in Oslo and the temperature in Berlin? So we can see that the temperature in Oslo was -8 and the temperature in Berlin between -6 and -4, so that will be -5. So the difference is 1, 2, 3 degrees. On a number line, to get from -8 to -5, we need to add 3. So that's a difference of 3 degrees. Here are some shapes made out of squares. A fraction of each shape is shaded. Match each shape to its equivalent fraction. 1 has been done for you. So this shape is matched to 7 tenths because we have 7 parts out of 10 shaded. So here we have 8 parts out of 10 shaded, but we don't have a fraction of 8 tenths. So what we can do is find an equivalent fraction, and one way to do that is by simplifying. 8 and 10 are both in the 2 times table, so if we divide both the numerator and denominator by 2, we get 4/5. So this shape here can be matched with 4/5. Now for this shape, we have 3 parts out of 10, so that's 3 tenths. Here we have 6 parts out of 10, but because we don't have 6 tenths as a fraction, we can simplify it. Again, we can divide both the numerator and denominator by 2, and that gives us 3/5. And here we have 5 tenths. If we divide both the numerator and denominator by 5, because 5 is a factor of 5 and 10, we get 1/2. So this shape here, we can say that 1/2 is shaded. What is 444 minutes in hours and minutes? So we know that there are 60 minutes in an hour, So what we really need to do here is divide 444 by 60. But the easiest way to do that is to count up in steps of 60 until we get to 444. So if we double to find 2 hours, 60 times 2 is 120. Then we can double again to find 4 hours. 120 times 2 is 240. So now to find 6 hours, we could have 2 hours plus 4 hours. So 120 plus 240. And that means 360 minutes is the same as 6 hours. If we add another 60 minutes to make 7 hours, 360 plus 60 is 420. And then to get to 444, we would just need to add another 24 minutes. So we have 7 hours and 24 minutes because 7 times 60 is 420, and then from that we need another 24 to get to 444. Stefan's watch shows 5 minutes past 9. The watch is 12 minutes fast. What is the correct time? So if it's 12 minutes fast, that means we need to subtract 12 minutes to get the correct time. So the watch shows 5 minutes past 9 or 9:05. So if we subtract 5 minutes, that would take us back to 9 o'clock, but that's subtracting 5 minutes and we want to subtract 12. So we need to subtract another 7 minutes because 5 and 7 make 12. So remember, there are 60 minutes in an hour. So if we subtract 7 minutes, that will take us to 8:53, because 53 and 7 make 60, and there are 60 minutes in an hour. So the correct time is 8:53. In the circles, write a multiple that belongs to each set. One has been done for you. So they've told us that 50 can be written in this circle here, because that's a number from 1 to 99, and it's a multiple of 10. Remember, a multiple of a number is in that number's times table. So multiples of 10 are numbers in the 10 times table. And if we count up in tens, we get to 50. But here, we need a number from 101 to 199. That is a multiple of 20. So multiples of 20, we have 20, 40, 60, 80, 100, but they're all less than 101. So we can write 120. That's in the 20 times table because 6 times 20 is 120, and it's a number between 101 and 199. We could also have 140, 160 or 180. But we couldn't have 200 because that would be more than 199. So for this circle, we need a multiple of 30, so a number in the 30 times table that's between 201 and 299. So if we know the 3 times table, we can work out the 30 times table. And we know that 7 times 3 is 21, so that means 7 times 30 is 210. And that's between 201 and 299. We could also have 240 or 270. And now here we need a multiple of 40 that's from 301 to 399. Again, if we know this time our 4 times table, we can work out our 40 times table. We know that 8 times 4 is 32, so that means 8 times 40, so 8 times 4 with a 0 on the end will be 32 with a 0 on the end, so 320. We could also have 360 because that's also between 301 and 399. Maria bakes cakes and sells them in bags. She uses this formula to work out how much to charge for one bag of cakes. The cost equals the number of cakes times 20 pence plus 15 pence for the bag. How much will a bag of 12 cakes cost? So to work out the cost, we have the number of cakes times 20 pence. So let's work out 12 times 20 pence. 12 times 20 is 240 because 12 times 2 is 24, and then we have an end zero, and 240 pence is the same as £2.40. But then we need to add 15 pence for the bag. So £2.40 plus 15 pence is £2.55. So that's how much the bag of 12 cakes will cost. Now, Olivia buys a bag of cakes for £5.15. Use the formula to calculate how many cakes are in the bag. So this time we know that the cost is £5.15. So £5.15 will equal the number of cakes times 20 pence plus 15 pence for the bag. So of the £5.15, 15 pence will be for the bag. So if we subtract 15 pence, that gives us £5. So the number of cakes times 20 pence must equal £5, because then when we add 15 pence for the bag, we will get £5.15. So what we need to think is what times 20 pence is £5. So we need to divide £5 by 20 pence. So here we have an amount in pounds, but here we have an amount in pence. So if we change £5 into pence, that's 500 pence. So we can work out 500 divided by 20. Remember, when we've got a division question with end zeros, we can cancel them and work out 50 divided by 2. So that's 25, which means that £5 divided by 20 pence is 25. So there are 25 cakes in the bag. 25 times 20 pence is £5, and then when we add 15 pence for the bag, we get a total cost of £5.15. The other way of working out £5 divided by 20 pence is to count up in steps of 20 pence until we get to £5. So if we know that one cake is 20 pence, we can multiply by 5. So 1 times 5 is 5, and 20 pence times 5 is 100 pence, which is the same as £1. But then, to get £5, we can multiply £1 by 5, and then multiply 5 by 5, and that tells us that 25 cakes will cost £5. So then, when we add 15 pence for the bag, we'll get £5.15. Here is a triangle. Measure the shortest side accurately in centimetres. So the shortest side looks like it could be this side here. So if we measure with a ruler, we need to make sure our ruler is lined up so that 0 is on one corner, and then when we look to the end of the line, we can see that it's between 5 and 6 centimetres. But it's 5 centimetres plus another 7 of these little lines, so that's 5.7 centimetres, or 5 centimetres and 7 millimetres. But just to check, let's measure the length of this line as well. So again, we've got our ruler lined up with the line, we've got 0 at the start of the line, and if we go to the end, this time we have between 6 and 7, and it's the 7th little line, so that would be 6.7 centimetres. Now we want the shortest side, so we don't want to use 6.7, we want 5.7 centimetres. And you get the mark for an answer between 5.5 and 5.9. Now measure the largest angle. So we can see that this angle here and this angle here are both small acute angles. So our largest angle is clearly this angle here. So what we want to do is line up our protractor. Notice the point of the angle is the point in the middle of this circle on the protractor. So we've got it lined up, and then our 0 line on the protractor is lined up with this line here. So then we can use the scale on the outside of the protractor, and if we go to this line, we can see that it's between 140 and 150, and it's right in the middle, so that's 145 degrees. You get the mark for an answer between 143 and 147 degrees. Write the 2 missing digits to make this long multiplication correct. So we can find the missing digits by following the same steps that we use for column multiplication. So with column multiplication, we start by multiplying our ones digits. So we have something times 6, and we have a 6 as the ones digit of our answer. So they could have done 1 times 6 to get 6, or they could have done 6 times 6, because that's 36, and so ends in a 6. So if they did 6 times 6, they would have got 36, and then written the 3 above. But if they did that, they would have 4 times 6, but they would need to then add the 3 to get 27, and we have 24 as the answer to 4 times 6. So that means we know that they must have used the 1. 1 times 6 is 6, and then 4 times 6 is 24. So now, to find this digit here, we need to think 1 times what ends in a 2, because when we're multiplying by the tens digit, we always have a 0 as the ones digit of our second answer line. So 1 times 2 is 2, and then 4 times 2 is 8. So this missing digit here must be a 2. Here is a number written in Roman numerals. We have CXV. Write the number in figures. So we need to remember that C is 100, X is 10, and V is 5. So our number in figures is 115. That's 1 in the hundreds because C is 100, 1 in the tens because X is 10, and 5 in the ones because V is 5. What number is halfway between 1.4 and 2.1? So to find the number halfway between, or right in the middle of two numbers, what we can do is add them together and then divide by 2. So this works for decimals, it works for whole numbers, it works for fractions, any two numbers. To find the number right in the middle or halfway between, we add the numbers together and then divide that total by 2. So 1.4 plus 2.1 is 3.5, and then we can work out 3.5 divided by 2. So we copy up our decimal point. 3 divided by 2 is 1 remainder 1. 15 divided by 2 is 7 remainder 1. So we need to extend with a 0 to write our remainder 1 in front of the hundredths digit. And we can do that because 3.50 is the same as 3.5. We can always write zeros on the end of decimals. And now 10 divided by 2 is 5. So that means 3.5 divided by 2 is 1.75. So that's the number halfway between these two numbers. The other way to work this out is to imagine a number line, and we have 1.4 and 2.1. So if we add 1/10, we'll get 1.5, and if we subtract 1/10 from 2.1, we'll get 2 or 2.0. Then we can have 1.6 and 1.9, 1.7 and 1.8. So our number, the number halfway between, will be the number that's right in the middle of 1.7 and 1.8, and that's 1.75, because remember, between tenths we have hundredths. So 1.7 is the same as 1.70, and 1.8 the same as 1.80. So right in the middle we have 1.75, so that's the midpoint, or the number halfway between these two numbers. The diagram shows a shaded octagon on a square grid. Line A joins two vertices of the octagon. We need to join two vertices to draw a line perpendicular to line A. So remember, perpendicular lines are lines that cross at right angles, or that would cross at right angles if we extended them. So we can join these two vertices here, and that makes a line perpendicular to line A, because we can see that we've made a right angle here. So a right angle is like the corner of a piece of paper or the corner of this screen. We could also join these vertices here. That's a line perpendicular to line A as well, because again we have a right angle where the two lines join. So now we need to join two other vertices to draw a line parallel to line A. So we can remember that parallel lines are like train tracks. If we extended them, they would go on forever without ever crossing. So a line parallel to line A could be this line here. So we could join this vertex, and then this red line is parallel to line A, because if we extended both lines, they would go on forever without ever crossing. Round 124,531 to the nearest 10,000, 1,000 and 100. So to round to the nearest 10,000, we can find the 10,000s digit, and that's always the fifth digit from the right if we have a whole number, because we have our ones, tens, hundreds, then our thousands, 10,000s and 100,000s. So then we underline the digit to the right. So if we're rounding to the nearest 10,000, that's our thousands digit. And then we can remember that if it's 4 or less, we round down. And when we round down, the digit that we've circled stays the same. Digits to the left always stay the same, and digits to the right turn into zeros. So that gives us 120,000. And that makes sense, because rounding to the nearest 10,000 means that if we counted up in steps of 10,000, so 10,000, 20,000, 30,000 and so on, we would get to 120,000 and then 130,000. But this number is closer to 120,000 than it is to 130,000. So that's why we round down. So now let's round to the nearest 1,000. We find our thousands digit and underline the digit to the right. This time we have a 5, and if it's 5 or more, we round up. So that means the digit that we've circled increases by 1, so this 4 becomes a 5. The 1 and 2 stay the same because they're to the left of what we've circled, and digits to the right turn into zeros. So that's 125,000 because we're rounding up. This number is closer to 125,000 than it is to 124,000. And finally, to the nearest 100, we find our hundreds digit, and we have a 3 in our tens, so we're rounding down. That means what we've circled stays the same, digits to the left stay the same, and if we're rounding to the nearest 100, our tens and ones digits will turn into zeros. So that's 124,500. A shaded isosceles triangle is drawn inside a rectangle. Calculate the size of angle A. So we're told that this angle here is 38 degrees. which means that this angle must be 38 degrees as well, because the shaded triangle is isosceles, so this line is the same length as this line. So now we have angles on a straight line, and angles on a straight line add up to 180 degrees. So 38 plus 38 plus angle A must give a total of 180. So if we add 38 and 38, that's 76, and then when we subtract 76 from 180, we get 104. So angle A is 104 degrees, because 38 plus 38 plus 104 gives a total of 180. Large pizzas cost £8.50 each. Small pizzas cost £6.75 each. 5 children together buy 1 large pizza and 3 small pizzas. They share the cost equally. How much does each child pay? So we need to work out the total cost and then divide that by the number of children. So divide by 5. So let's work out the cost of 3 small pizzas. So that's £6.75 times 3. That gives us £20.25. And if we add the cost of 1 large pizza, so add £8.50, that gives us a total cost of £28.75. They share the cost equally, and there are 5 children, so we need to divide £28.75 by 5. So we copy up the decimal point. 28 divided by 5 is 5, remainder 3. 37 divided by 5 is 7, remainder 2. And 25 divided by 5 is 5. So that means each child pays £5.75, because that means they pay £28.75 altogether, and that's the cost of 3 small pizzas and 1 large pizza. 7 children measured their heights. What is the mean height of the children? So the mean is the average, and we find the mean by adding up the total of what we have and then dividing by the number of things. So here that means finding the total height in centimetres and then dividing by the number of children. So 144 plus 136 is 280, plus 142 is 422, plus 143 is 565, and then we can continue adding the total of what we have, and that gives us 1015. Now we have 7 children, so because the total height is 1015 centimetres and we have 7 children, that means we need to divide 1015 by 7, and that gives us a mean height of 145 centimetres. 100 girls and 50 boys were asked which kind of chocolate they like best. These 2 pie charts show the results. Dev says the pie charts show that more girls than boys liked milk chocolate best. Dev is correct. Explain how you know. Well, if we look at the pie chart for boys, we can see that half of the boys like milk chocolate best, and half of 50, or 50 divided by 2, is 25. So this pie chart shows that 25 boys like milk chocolate best. But 25 is 1/4 of 100, and we have 100 girls. But we can see the section of the pie chart for milk chocolate is more than 1/4, so that will be more than 25 girls. In fact, the pie chart slice for milk chocolate is almost half, so it will be just under half of 100, or just under 50 girls. So half of 50 means we know that 25 boys like milk chocolate best, but over 1/4 of 100, so over a quarter of the girls, so more than 25 girls, like milk chocolate best. 1 gram of gold costs £32.94. What is the cost of half a kilogram of gold? So here we need to know that 1 kilogram is the same as 1,000 grams. So that means half a kilogram is the same as 500 grams. So if we know that 1 gram costs £32.94, to find 500 grams, we need to multiply that amount by 500. Now we could do that using long multiplication, or we could first multiply the amount by 1,000 to find the cost of a kilogram of gold, and then we could divide that answer by 2 to find half a kilogram. So if we take £32.94, we can multiply by 1,000 by copying down the decimal point and then moving the digits 3 squares to the left. So when we do that, because we have an empty square in front of our decimal point, we can write a 0, and now the decimal point is on the end, so we have a whole number. So that means 1 kilogram of gold costs £32,940. But we want to find half a kilogram, so we need to divide that amount by 2, and that gives us £16,470. So that's our answer. The other way to work out £32.94 times 500 would be to first multiply by 100 to find 100 grams, and then we could take that answer and multiply it by 5 to find 500 grams or half a kilogram. Because if we multiply by 100 and then by 5, that's the same as multiplying by 500, because 100 times 5 is 500. So to multiply by 100, we can copy down the decimal point, and then because there's 2 zeros in 100, we can move the digits 2 squares to the left. So that gives us 3,294, and then we can multiply that by 5, and we get £16,470, so the same answer. On Saturday, Lara read 2/5 of her book. On Sunday, she read the other 90 pages to finish the book. How many pages are there in Lara's book? So we know that she read 2/5 or 2 parts out of 5 on Saturday, and that means on Sunday she read the rest, so she read 3/5, and that was a total of 90 pages. So using a bar model, if we know that 3 bars make 90, to find each bar we can divide 90 by 3, and that's 30. So each bar on our bar model represents 30, and we have 5 bars, so if we multiply 30 by 5, that gives us 150. So that's the number of pages in Lara's book. The other way, instead of using a bar model, would be to think if 2/5 was read on Saturday, then 3/5 was read on Sunday. So 3/5 of the total number of pages is 90 pages. So here we have a missing number fractions problem. Now normally to find a fraction of a number, we divide denominator times top. So divide the number by the denominator and then multiply that answer by the numerator. But here, because it's a missing number problem, we need to use the inverse, or do the opposite. So we can divide the answer by the numerator, and 90 divided by 3 is 30, and then we can multiply that by the denominator, and 30 times 5 is 150. And you can see that we follow the same steps, so divide by 3 and multiply by 5, whether we're writing it as a missing number fractions problem or as a bar model.